So I went through everybody's program who submitted your assignment 1 correctly and gave you comments. They should be pushed to your GitLab repositories. If you didn't fill in the submission form, then I don't know where your repository is, and so I didn't provide you any review. Make sure that you, however, if you did not get reviews from me, make sure you take a look at the comments I'm doing here and ensure that your code doesn't have these same mistakes. The submission for the final version of assignment 1 is due very shortly. I think it's due tomorrow. It shouldn't take you very long to address it. It's a intentionally very, very simple assignment. And assignment 2, which we'll cover in a moment, is due also very quickly because it's also just a small tweak to what we've done so far. So let's take a look at some of the things I saw wrong. First of all, make sure that you always use the base member initialization section in order to initialize your data members, as we discussed in class. In this particular case, it's really not the end of the world if you don't use the base member initialization section. The performance will be the same, but it's a really good habit to get into. And so if you do it for everything, then you won't ever have to worry about, gee, did I forget to do this correctly? So make sure that you always use the base member initialization section rather than doing the initialization in the body of the constructor itself. Another couple things, make sure that you don't check whether or not the M-array pointer is null before you delete it. Delete already does that, so doing it yourself is just a waste of time. And second thing is make sure that you don't bother resetting M-array to the null pointer after you delete it. There's no need to do that. It's extra work. It's confusing because people look at that and go, gosh, I wonder why they did that. Once an object has been destroyed, then there's no good reason you should ever be able to access it again. And so as a result, you're just doing unnecessary work for no particular gain. So I'm not sure if anybody ever told you to do it otherwise, but you don't need to do these kinds of things once you've deleted something. The object is gone. Now, another thing several people did, and this actually showed up in a couple of different places, so I commented it each time, but it's the same mistake. When you allocate something as an array in C++, you have to use slightly different syntax when you delete it. And we've covered this in class. If you don't remember what we covered, then simply go and Google deleting an array in C++, and you'll find out what you need to do. In fact, that's a really good thing to get in the habit in general. Whenever you come across something like a comment from me or something we covered in class and you're a little puzzled, of course, feel free to post to Piazza. But it's even better habit to get into to go and look it up on the web first, see if there's not a Stack Overflow article or some other source that gives an explanation of what you're asking about. And the reason for that, of course, is while I'm always happy to answer questions, at some point this class will be over and you'll be on your own. And so if you get in the habit of looking these things up and then trying to puzzle it through by the resources available online, you'll learn some techniques that you can use throughout your career. Another thing you might try doing is looking it up online, and then if you either are still confused or you're not sure quite what it means, then go ahead and post to Piazza along with a link, and then we can work on that together. So just trying to get people to be self-sufficient because it's a good habit to get into. But don't feel like you always feel like you should be welcome to ask questions. Not a problem at all. Here's a couple other things people were doing. Overly complicated code for some of the stuff like is non-null. This code is just way too complicated. All you need to do is just a simple expression that checks to see whether M-array is equal to the null pointer or not. And that's just a one-liner, really, to say return and then do the expression. So it's good to get in the habit to write code like that. Try to avoid complicated if-else statements if you can. Do that instead. Here's the get method. You don't need to check whether or not the get is returning a null pointer. In fact, not much you can do anyway. In fact, look what's happening here. This code says if M-array equal null pointer, return null pointer. Well, that's redundant. You might as well just return the M-array, and if it's null, it'll be null, and if it's not, it's not. So that's a good example of a completely gratuitous check that does nothing but confuse the reader because it looks like there's some purpose behind this, but of course, in fact, it doesn't really make any sense at all. Let's take a look at some other examples. So here's an example of the get reference method. This code is too complicated. You don't need to have all this stuff in here. And it's also incorrect if is non-null returns false, then this was returning the wrong value. So this code again should be really, really simple. And this implementation is just wrong. So be very, very careful and wary of that. Similar comment here. Make sure that you get comfortable using the operator subscript notation here rather than the pointer arithmetic dereference solution done in this piece of code. They do mean the same thing, but I think most people would be more, it's more intuitive to see a subscript operation than to do the pointer arithmetic, all things being equal. So it's just a good habit to get into to learn how to do that. This is the release method, which, as you can see here, has this very similar problem to the destructor. You have to remember that when you allocate something as an array, you have to delete it as an array as well, and you have to go look up and see what the special syntax is for that. If you are in a position to run memory checking tools in your code, it'll detect a mismatch and flag that. So that's another thing to get in the habit of. Unfortunately, if you're not using Linux, then you don't have Valgrind at your disposal, but there are other tools out there that you could probably leverage if you need to. Down here, for the release method, again, you don't need to check to see whether the value is a null pointer. You can simplify the code and it'll work just fine the way that you can write it without making that check. Here's yet another problem with deleting incorrectly. So make sure you use the right syntax to delete an array, and make sure you're consistent throughout all the different parts of your code that need to delete things. Here's an example where something's missing. So reset is supposed to delete the pointer that already exists before you reset it. So that's missing. So make sure you put that in and make sure you use the right syntax. And then here's the final frequently made mistake that I saw people do. It's actually okay to do self-swapping. That won't cause any problems. And in fact, it's sort of rare to do self-swapping. And so making that check every time is probably extra work that's unnecessary. It's good to do that kind of a check for self-assignment checks, but in this case, it's fine to do self-swapping. And also, please use the std swap method instead of writing the code out yourself. It's just a good habit to get into wherever possible to reuse the code that's already in STL and designed to make your code a little bit more concise. So those were the key things I wanted to talk about with respect to frequently made mistakes. What you need to do is go back through your code, take a look, make sure that you address my comments. If for some reason I missed one of these things in your code, you're still on the hook to do it, to make sure it works properly. And then your solution, your final implementation submission will be due, I think, tomorrow. You can always go to the Wikipedia, or sorry, to the wiki link here on the CS251 GitHub repository website and find out when all the assignments are due. And all that information is also available on Piazza. By the way, make sure you get in the habit of reading Piazza at least a couple times a day. There were people who obviously missed my posting last week informing everybody they need to submit the form so I'd know where to find your code. And so they missed the deadline, and that was clear. They weren't reading the Piazza forum. There were also people, I posted all the people who had submitted the code correctly, and a number of people didn't check that until over the weekend. So make sure that you're checking these things pretty much every day, because there's lots of stuff that goes on, and you don't want to, definitely don't want to fall behind in this class because it goes really fast. Okay, so that's the end of my frequently made mistakes discussion. So here is the question. The question has to do with get reference. So it turns out with C and with C++, there's a couple of different ways to access the ith element relative to some base address. And one way to do it is to do just a simple something like this. Let's comment this code out for a second so we can ignore it. One way to deal with this is to say return m array sub I. That's by far the best way to do it, because that's very clear. You're getting a reference to the ith element, no problem. Now if we were to go here and dereference this, then we would be, I think what we want to do here is not do that. We want to go ahead and return it the other way, because that's going to get us the object it's pointing to, which is not what we want. So the other thing, I think the other part of the question was, you can't say M array plus I, because that's actually not going to be a reference. That's going to be a pointer. That's going to be adding I to M array. So it's going to be a pointer. So this is actually of type, let's see, what would this be a type of? This would be allocation tracker star. Let's call it AP. So that would be this. And so as you can see, looking at the code above, in order for that to work, you have to say return AP. And that what that'll do is that'll take the pointer and then dereference it, and then it returns a reference to that. So you could do that. That code is not incorrect. It just is awkward looking. So it's much better to get in the habit of doing it correctly, which would be to say return M array sub I. Oops, sub I. So that's what you want to do in that case. And again, the way to play around with this is to try the different techniques, see what happens, and then over time it'll become second nature as to what's really going on in here under the hood.